Hello, this is Michael Kogan. This is for tests on chapter 25 to 26. So to start off with, let's label what problems these constants will be here for. So this will be through problem E through E. So let's write that on the side. E through E. Okay. And A through E, the constants we are given are our resistor is equals 10 times 10 to the power of 6 ohms. Our capacitor, or capacitor's capacitance, I should say, so I'll just label that as C, goes 3.6 microfarads, but we know that's 10 times 10 to the negative 6 farads. And our EMF battery is outputting 12 volts. Internal resistance is negligent, I believe. And before you close the switch at t equals 0 to complete the circuit, capacitor is uncharged. Find the final capacitor charge. Okay, so for that, let's draw a little diagram just so we know what we're talking about. Boom, boom. Here's the capacitance. Right here, there's the switch. And here's the battery. Okay, so this one we don't need the diagram for right away, right? But it just kind of helps you get the type mindset for it. But for this one, we can use the formula. So I'll write this out. To find Q of F, we can use the formula. Use Q of F equals C times E, right? And that's a pretty simple problem to solve. That is just 3.6 times 10 to the negative 6 times 12 equals. Pull my calculator. I'm so sorry about that. And just remember the C and the E, just where we get it from. 3.6 times 10 to the negative 6 times 12. We're not taking the 10 to that. Sorry about that. We get 4.32 times 32 times 10 to the negative 5. We can check that is correct. So that is for problem A. For problem B, find the initial current. Okay, to do that, we can just use the V equals IR rule. So just take, since it's not discharging, we're just finding the initial current, we can use defined I, initial, we use V equals IR, and then we can transform that into V over R equals I. And we do know that V, matter of fact, is 12. It's E, same thing pretty much in this case, divided by 10 times 10 to the 6th power, and that is 12. 10 times 10 to the 6th. That is 1.2 times 10 to the negative 6. And that will be in amps. Sorry, let me make sure I coulombs amps. Okay. And then for C, the question is find the time constant. So something here to remember is that the time constant is R times C. It's what you divide the time by in the larger formulas that we'll get into later. But we write down time constant as tau. So let me clarify that. To find tau, we use tau equals RC, resistance times capacitance, and we can just plug those in. All these problems are pretty simple. This is RC currents, by the way, problem 5. So they're all very simple to solve. 0.6 times 10 to the negative 6 times 10 times 10 to the 6 equals, and that will equal 36 seconds. All right. All right, sorry, I was just making sure my audio was good. All right, and then for D, part D, is find the fraction of the final charge on the capacitor at t equals 15 seconds. Okay, so for this, we will have to use the formula. So first, to find the fraction. So first, we'll just label as, well, to find Q. So that's going to be the smaller charge of these two. The final charge on the capacitor at t equals 15 seconds. Okay. So to find this value, we must use the formula. Sorry, my S's look a lot like 5s. I need to start working on that. But to use Q equals Q final times 1 minus e to the negative t divided by RC, or as you remember, RC is tau. So we can plug that all in to 4.32 times 10 to, let's recall, negative 5 times 1 minus e to the negative 15 divided by 36. All right. So then we just plug that into our calculator and we will get 1.47 times 10 to the negative 3 coulombs equals Q. And to find Q divided by Q of F, or Q final, that's the fraction that we're looking for, we just divide them. So it will be 1.47 times 10 to the negative 5 divided by 4.32 times 10 to the negative 5. And then we're able to get 0.341. And since the units cancel out, that's just the ratio. So we'll just leave it like that for now. And then for part E, now it wants us to find the fraction of the initial current present at t equals 15 seconds. Okay. So to find the initial current, we will need to use the formula. So here, let me write this out. To find I over I naught at t equals 15, use I equals I naught, which we've already found, at I naught times e to the negative t divided by RC, or otherwise tau, right? And then we already have I naught. Remember, in part B, we found the I initial, which is I naught. This is a different way of calling it. which is 1.2 times 10 to the negative 6, uh, not to the power of 10 times negative 6, times e to the power of negative 15 over 36. And then once we all multiply that out, we will get 0.6, or sorry, my bad. We'll get 7.91 times 10 to the negative 7. Okay, and then we do the same thing. Then use I not, or I divided by I naught. And that will go to 7.91. 1 times 10 to the power of 7, negative 7, divided by 1.2 times 10 to the negative 6, which we got from part B, and that will equal 0.659. No units again, the amps and amps cancel out. All right, so that is our final answer for E. Now moving on to different constants. This one will go from F to G, very short. F to G. So first we're given the capacitance. Capacitance is equal to 2.2 microfarads, or for the sake of ease of reading, we'll do 2.2 times 10 to the negative 6 farads. So a 2.2 microfarad capacitor initially is charged 4.2 microcoulombs. You connect it in series with a 4 mega ohm resistor in an open switch. If t equals 0, the time when you close the switch, at what time will the capacitor be charged to 1.2 microcoulombs? Okay, so we have that, and then we have uh, its initial charge, so Qi, equals 4.2 times 10 to the negative 6 coulombs. Its resistor equals 4 times 10 to the 6 ohms. At t equals 0. So to solve this, we'll want to use the Q equals Q naught times E, right? The discharge formula, right? Since it already has an initial current or initial charge. So to do that, let's write this out so that we are all on the same page. To find T when Q equals 1.2 times 10 to the negative 6 coulombs, use this formula. Q equals Q naught times e to the negative t divided by tau, or RC. All right, so then we kind of want to solve this equation, right, for t. So we can take, I'll kind of shorten it up for y'all, but you can take the ln of Q final, there's Q initial, times it by RC, and this will all be negative, equals T, right? So once you solve it for all of that, you will get, you can plug in your numbers, 1.2 times 4.2, since the micros cancel out. All right, so then you're just left with that. Times 4 times 2.2, since the mega and the micro will cancel out. Then you will get 11.0245 seconds. Or 11.024 seconds, aka just 11 seconds. Sorry, I can't even read my own messes. Uh, but with that, we are done. Okay, and then with G, we're going to ask a very similar question. At that time, right, so this previous time, 11.024, right, and T equals 11.024 seconds. Find I, so the current of the circuit. So to do that, we will need the initial current. But there's another formula where the initial current equals uh, negative Q naught divided by RC. Okay? So we can use the formula. Let me just break that off. We can use the formula I equals negative Q naught, so initial charge, divided by RC times E to the negative T divided by RC. And since we have all the values of that, we can just plug in everything. So then we will get negative 4.2 microcoulombs divided by RC, which, as we talked before, 2.2 times 4, since the mega and micro cancel out, times E to that time, negative 11.024, and again, divided by RC, 2.2 times 4, or 8.8, right? But that value will be uh, 1.36 times 10 to the negative 7. And that will be in amps. Sorry, run out of room, so I'll rewrite it down here just for our sake. Times 10 to negative 7 amps. Okay. So again, still very simple. These are very simple currents. You just, since the formulas already pretty much exist for us. Okay. So then we will move on to H through. Let me make sure IJ. So H through J. So it says you connect an unknown resistor in series with an 8 microfarad capacitor and an open switch. Before you close the switch at t equals 0, the capacitor has charged 5.5 microcoulombs. At t equals 17 seconds, the charge has decreased to 1.1 microcoulombs. Find the resistance of the resistor. All right. Okay. For this one, it's a. I already read this one out, so we'll just write down the variables I use. So we know that R equals question mark. We don't know that one, right? We know that capacitor 1 equals 8 microfarads. And but for ease of reading, sorry, I'm trying to force this habit recently, times 10 to the negative 6 farads. And capacitor 2, which will be connected after we close the switch, has a charge of 5.5 times 10 to the negative 6 farads. Oh, I'm sorry. Not farads, coulombs. At before you close the clutch. Oh, I am so sorry. I don't know how I read that out and then completely forgot what I was talking about. the charge as that after you close the switch. So this is before. This is the initial charge. Uh, and at time t equals 17 seconds, the charge is decreased to q equals 1.1 times 10 to the negative 6 coulombs. Okay, so from this, we can in fact find the resistance. So for H to find R, we just need to use we use we will use Q equals Q naught, which is the initial, E times T to the negative, right, R C. Right, and then we can end up solving this for we can do negative Ln. I am so sorry. My cat just jumped up here. Sorry. Uh, we can use negative ln of 1.1 divided by 5.5 because micros cancel out, right? Times 8 times 10 to the negative 6 divided by negative 17 equals 1 over r, right? So we're able to plug in this answer, and then we just have to divide that answer by 1, or 1 divided by that answer. So when we do that, we will get roughly R equals 1.32 times 10 to the 6th ohms. Okay. And then for I, the question for I is find the current in the circuit just after you close the switch. So it's asking for us with that charge of 5.5, what is the current just after you close the switch? Okay. So that's a pretty simple question, right? To find I naught, I naught at t equals 0, we'll just treat it like it's 0, right? Use I naught equals negative q. I don't know if you guys recall this equation. Q naught divided by RC. And then we're able to just plug in our values for that, right? So recall that Q naught equals negative 5.5 times 10 to the negative 6. I just threw in that negative with it. And then R is 1.32 times 10 to the negative 6 times 8 times 10 to the negative 6. And that will equal out to 5.207 times 10 to the negative 7. Apologize. The resistance is not a negative 6, it's the power of 6. And that will be in the ampage. Okay. After that, we'll be looking at problem J. And J is asking us to find the current, so we'll just say I here, at t equals 17 seconds. All right, so let's remember up here, at t equals 17 seconds, the current is 1.1 times 10 to the negative 6. Now, Looking at actually this equation again, we won't even need that, right? Because we already have I naught. And once we have I naught, we can use I equals I naught times e to the negative t divided by r c. Right? And once you plug in all those values, you'll get 5.207 times 10 to the negative 6, or 7, my bad, times e to the negative 17 divided by 1.32 times 8. Since then, times 10, or 10 to the negative 6 and 10 to the 6 cancel out. And after that, you'll get I equals 1.04 times 10 to the negative 7 amps. All right. With that, we'll flip to the next page. And then we can move on to K through L, our final problems. Okay, for K through L, the question says you connect an initially uncharged 6.4 microfarad capacitor in series with a 5 mega ohm resistor and a battery with EMF 12. After letting the capacitor charge for 51 seconds, you disconnect it from the circuit and connect it in series to an open switch and a 6 mega ohm resistor. Find the charge on the capacitor when you disconnect it from the first circuit. Okay, so this is pretty simple as well. Right, so let's start off with writing everything. We'll write down the first capacitor as C. We'll leave it like that since we don't have a second one, and that's new connected in circuit. So 6.4 times 10 to the negative 6 farads. And then resistor 1 equals 5 times 10 to the 6 ohms. And EMF equals 12 volts at t equals 51 seconds. R2 equals 6 times 10 to the 6 ohms. Okay. So to find this first one, we can just use, since it's asking for find the charge on capacitor when you disconnect it from the first circuit. We'll need to be able to find Q. And we can use the formula to find Q. We will need Q of F, the final charge, the maximum. Use, obviously, Q of F equals C times E. So for that, we'll plug in 6.4 times 10 to the negative 6 times 12 volts equals 7.68 times 10 to the negative 5. And since, we ran out of paper, we'll write that down here. QF equals 7.68 times 10 to the negative 5 coulombs. Okay, now that we have that, we can move on and plug it into this one. Now use Q, or sorry, you better remember to keep lowercase. Q, lower, equals Q of F times 1 minus e to the negative t divided by r c. Okay. 6.4. Yep. Okay. And then we're able to plug that in with 7.68 times 10 negative 5. Actually, let me just move down to a new one so it's not too cramped. It will be 7.68 times 10 to the negative 5 times 1 minus e negative 51, as that is the time, divided by 5 times 6.4, since, the 10 to the power 6, the mega cancels out with the micro when you multiply. And that will equal about 6.12 times 10 to the negative 5 coulombs. All right, and that checks out with our answer. Now, the next question, and sorry, I forgot to write down K for that. Our next question, L. Find the charge on the capacitance 70 seconds after you close the switch in the second circuit. So remember, this is the charging formula, right? So that's it when it's charging. Now we'll want the discharging formula. And the discharging formula goes here. To find Q, and I'll write down a D down here. I'll write down a C up there. Start discharge, charging. D at 70 seconds. T equals. We'll the only resistor in this circuit now, after it's discharging, is R2. So the second one, this one right here. And we'll want to use the discharging formula. So it'll be Q equals Q naught, right? Which is this value right here, equals Q naught times E to the negative T divided by RC. Okay, so we'll move back down here and we'll plug in our values. 6.12 times 10 to the negative 5. Remember, it's this value right here. Times E to the negative 70, since that's the time. And times R, which will be 6 times C, 6.4. So remember, the micro and mega cancel out. And once you plug that in, you'll get 9.89 times 10 to the negative 6 coulombs. So that'll be at 70 seconds after you connect it. All right, so that's all of them. I hope this was helpful, and thank you for watching.